Hello, all, and welcome back to the lesson 5 in chapter 6, that is the projectile motion. The learning objectives of this lesson are solve physical problems involving velocity and solve problems on projectiles. In the coming sections, we will look into both of these objectives. The key words which you'll come across in this lesson are projectile, motion, acceleration, velocity. You might have come across few of these already beforehand. Anyways, we will recall them as we continue in the coming sections. The first topic here is very basic. It is to identify initial conditions. Now, you might have remembered, now if you have a position, say this is the position, say P, position is P. Now, if you derive the position, you will get velocity derivation. So derivation will give you velocity, and if you derive the velocity, you will get acceleration. This is derivatives. Now we are dealing with integrals, integration. It starts from the other way around. If we integrate acceleration, here it is d by dx, okay? dy by dx, that's basically. If you integrate acceleration, you get velocity. If you integrate velocity, you will get the position. So this is how it works. So now it is very crucial to understand what is the initial conditions. Initial conditions means always at the time 0. So now y of t might be the height or the position at particular time t. But whenever t is 0, time is 0, that means it's initial condition. Now here let us see, an object is dropped from a height of 80 feet. You can see the 80 feet is where it starts. It is dropped from that feet. So now imagine this is a building. This is a building, and say this is somewhere 80 feet over here, and an object is being dropped from here. What is the initial height? With respect, this is 0, it's at 80 feet, so this will be the initial condition. At the time 0, it is already at 80, so y of 0 will be 80. Sorry for that. Now, there is no velocity information, so y dash of 0, that is the velocity, is 0 because it's not mentioned. Now, in the next problem, an object is dropped from a height of 100 feet. Here, the same thing, the initial velocity, initial height, the initial position is basically 100, whereas the velocity is not mentioned. In the third problem, we have an object released from a height of 60 feet with an upward velocity of 10 feet per second. Now, this is important because we have two things. An object is released from a height of 60. Okay, y of 0 is 60 feet with the upward velocity. Upward means positive, downward is negative. Upward velocity of 10 feet per second. So y dash will be 10. So this is the answer, plus for its upward. And it is y dash of 0 is 10 feet per second, whereas y of 0 is 60. Try this by yourself. Take time, pause the video now and solve it by yourself. I am sure you're all thorough in these type of questions by now. So over here, object is released from a height of 20 feet. Y of 0 is 20. Downward velocity is 4 feet per second. So y dash of 0 is minus 4. Why? Because it's downward. That's it. Now we will see a problem on finding the velocity of a diver at impact. So now, before we solve this problem, see now all the problems will be in this type. It is real world, it's simple, it's practical problem. You know, we have done these problems before. Basically, you have to integrate acceleration, get the velocity, integrate velocity, get the position, and then see what you require. Now, I want to talk about this impact. What does impact mean exactly? Now over here, we will see the question and then I'll come back to this impact. If a diving board is 4.5 meters above the surface of the water and a diver starts with the initial velocity, see, the initial height or the position is given and the initial velocity is given in the upward direction, positive. what is the diver's velocity at impact. So now a person is diving board, in the ocean, they'll dive scale in the boat. So that is what he's doing. So he's already up above. The waves are going like this. He's up above over here, maybe at 4.5 meters. Okay, very high. So now they want to know, with the velocity already given, they want to know the diver's velocity at impact. Now, first thing, let's just write the given over here. H naught, H of 0 means initial condition. Height is 4.5. Sorry, this is 4.5 meters. I apologize for this mistake. It should be meters, not feet. And now over here, the velocity is given as 2.4 meter per second. I am sorry, this is m and this is plus 2.4. Okay, that is it. Now I will stop over here. Okay, let's see this. The step 2 before I go to impact. Let's see. We need to find h dash of t where t is the impact time. Okay, now what is this exactly impact time? Now, impact time means where it touches the particular, where it touches zero height. Now, let's see, it's basically like the intercepts, okay? Let me draw a straight line. So now, imagine you go up like this and you come down over here. The impact over here is this particular point. Now, okay, that is not so accurate. Now it's something like this. You start from 4.5, right? Now we start from 4.5, and when is the impact? At this particular point, when it touches zero. So what do you understand? The impact velocity means h of t will be equal to 0. We don't know at what time. We don't know exactly at what time it touches at 0. But whenever this entire equation h of t is equal to 0, that is the impact time. I hope this is clear. You start at what? 4.5, right? Okay, at the time 0, at 0 time you start at 4.5. It eventually goes, right? At what time will it come down to 0? So that is the thing. At what time t? So that particular time is to be found out, needs to be found out. It's very important. That time t is the impact time, and that velocity at that particular time is the answer. Anyways, we will now solve it and then you will understand much better. Now we have find the velocity by integrating acceleration. I hope you all know what's the acceleration over here. H double dash. See, now we here position is h, velocity is derivative of it, so h dash. Acceleration is double derivative h double dash. Now you must know this by now. Acceleration due to gravity is negative 9.8 meter per second square. We have already used this before. If you have forgotten, no worries. Minus because it's downwards, acts downwards, and this is a constant 9.8 meter per second square. Now integrate this, you will get the velocity. Integration of h dash, h double dash of t is h dash of t. So integrate minus 9.8. What happens? Dt is, because you have to integrate this, it is minus 9.8 t. Because the integration of any constant, if it's 1, it is x. Okay, because if it's dx, now here we are dealing with dt. So we don't write x, we write t. That's the only thing. Now don't forget the plus c. A constant will always be added. Okay, what is that constant? How do we find it? Very simple. You know the initial velocity h of 0 is 2.4. So substitute over here and solve. See, what I mean is substitute the value of h dash of 0. When h dash of 0, what happens? Minus 9.8 t is 0, right? Plus c. So instead of t over here, we are making everything t equal to 0. That is the initial time. Because we know when h dash of t is 0, it is 2.4. So all we are doing is instead of t we put 0 and over here we put 0. Okay, now solve it. H dash of t is 2.4. So we know 2.4, this becomes 0 is equal to c. So this is the constant value. So now what we write is the proper equation of the velocity. The velocity equation h dash of t is 9.8 t plus c. That is c value we found out is 2.4. This is the velocity equation. What next? Next, we will find the impact time, which is very, very important. To find the impact time, we need to find the height, that is h dash of t, h of t, sorry, that is integrate this velocity, you will get the position or the height. So initial position, initial height. Integrate this, that is minus 9.8t plus 2.4. When you integrate it, look what happens. See, there is t, so it is 9.8 t square divided by 2 plus 2.4 just t. This 2 and 9.48, when you put it in the calculator, you will get 4.9. So minus 4.9 t square plus 2.4 t plus c. That is the answer. But again, we don't know what is c. What do? We let us put t as 0 and let us solve. T will be 0. So instead of t over here, everywhere it's 0. What is the h of 0 value? It's 4.5. So 4.5 is c, because this cancels. Anything that is having t will cancel. This cancels. It's 0, 0. 0 plus 0 is 0. C is equal to h of 0, that is 4.5. Next, h dash of t equals minus 4.9 t square plus 2.4 t, but the c value we found out is 4.5. Generally, for a quadratic or linear function, when we find the initial value, whatever is this initial value will be the answer. Only when it's trigonometric functions, when you have trigonometry over here, don't blindly take the c value as the initial conditions. C value might change depending on whether you have sine or cos. But when it's quadratic, this is linear, it's a quadratic, you can easily understand all this will become 0. So your constant will be basically the your constant value will become the initial conditions. Now, this is important and crucial. Always the impact, the height will be 0. I told you, right? You start with over here when the height is 0, the position. So at what time h of 0 will be 0? So this is very important. Sorry, it is not h of 0, it is h of t. Okay, now that is very crucial, because sorry, this is okay, this is doesn't make sense. H of 0 is not 0, h of 0 is 4.5. I apologize for this mistake. It is h of t. I'll change this error. It is h of t must be equal to 0. So now just equate this to 0 and solve for the time, you will get the answer. So just equate it to 0. We have done this many times. Quadratic equation, mod phi 3. So all you need to do is put in mod phi 3, you will get two answers. Remember, negative time is not possible, so this is the correct answer. T is 1.23. This is the impact time. You will have only one correct answer. Now substitute this impact time of 1.2 seconds in the velocity equation. To find the impact velocity, just substitute t as 1.23 over here, or 1.2, and you will get the answer. That is the particular answer. So now again, I'll just recall over here. This h of t must be equal to 0. You will find the time. Take only the positive value of time. And then what do? After you find the time, put it back in the velocity equation. Instead of t, put 1.2 seconds, which is the impact time. So at impact time, over here t impact time, you will find the velocity. That is, just substitute over here, instead of t 1.2, it's negative 9.36. That is the impact velocity. We will solve more problems on vertical motion. Here we have a problem that a ball is propelled straight upwards from the ground with initial velocity 9.6 meter per second. Ignoring air resistance, find an equation for the height of the ball at any time t. Also determine the maximum height and the amount of time the ball spends in the air. So this is a long question. They have asked many things, but always whenever you have such problems, on projectiles or vertical motion or acceleration, first thing, see what is given. Write the given. That is initial height. They have not mentioned anything about direct meter is not mentioned. Meter per second, is always velocity. So initial velocity is upwards from the ground plus 19.6. Height, nothing is given, so it's 0. Okay, so now what happens? Next thing, see what do you want to solve? See what are they asking you to solve? Now here they are asking you height of the ball at any time t, that is h of t. Okay, it's very simple. Integrate the acceleration, that is 9.8 minus 9.8 meter per second. You will get h dash of t, that is velocity, and integrate this h dash of t, you will get the height. So it's very simple. Okay, that is fine, but that's not it. They want the maximum height and the time in air. So let us start solving it one by one. So find the velocity integrating acceleration. If you do not know this, I would recommend you to pause this video, go back to the previous video, watch it, be thorough, and then come to this. Now, we have done the same thing in the last video, last section, last problem over there. So you have to just find the, you should know this acceleration. You have to just find the integral. So h double dash of t means acceleration. Integrate this, you'll get velocity. H dash of t. That is integral of minus 9.8 dt. That will be minus 9.8 t, because it's a constant, so t will be multiplied, plus c. What is the c? Constant of acceleration. You have to find this. How do you find this? You know the initial velocity is given h dash of 0. Substitute. To find the c value, substitute this h dash of 0 over here. When h dash of 0 happens, this t will become 0. Every way t is 0, right? So this t becomes 0. What is h dash of 0? 19.6. That is the c value. In the last video, I told you, whenever it is just linear or quadratic, you don't even need to solve it. You know the c value will be the same thing, okay? So now h dash of t is minus 9.8 t plus the constant of acceleration is 19.6. Okay, we have found h dash of t, but this is not what we want. We want the position, say over here h of t. So find equation for the height by integrating the velocity. When we integrate the velocity over here, it will be minus 9.8 t square by 2. We had this similar equation in the last problem. The same type of similar problem, I mean similar answer we got. Now we will be minus 9.8 divided by 2 is minus 4.9 t square. When we apply integral formula, it happens. Then this over here is a constant, so you just add t, and then you have to add the constant of integration c. How do you find the c value? Substitute. It will be 19.6. Sorry, it will be 0. So substitute over here everywhere where t is there as 0. Over here, t is 0, 0, 0. What is h of 0? Initial height is 0. That is equal to this. All goes, and what is remaining? C. That is equal to 0. So a height, equation for height of the ball at any time t is negative 4.9 t squared plus 19.6 t. C is 0, so we don't write it. The first part is over. Now we need to find the maximum height and the amount of time the ball spends in the air. To find the maximum height, what we do is, you must always remember this. I'll explain why this is. The maximum height always occurs, even in the coming problems. You will see the maximum height occurs when the velocity is 0. What does that mean? Now imagine like this. Okay, you start projecting something like this. It goes up and then it goes down, right? So when is the height maximum? When, see, the velocity is increasing, and after a certain point it will start decreasing. All this position over here it's plus, here it's minus. You can see the slope plus and minus, right? When is it maximum? When the velocity is 0. See, whenever this particular point where it is null, in the sense it changes from plus to minus at 0, that is the maximum height. Always remember h dash of t must be 0 for the maximum height to occur. Okay, so why? Because it goes up, 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 and when it is 0 over here, the velocity is 0, the slope is 0, that is h dash of 0, h dash of t is 0. Here, the maximum height occurs. I hope this is clear. So all you need to do is, what is the h dash formula? Over here we have, right? So we need to find the maximum height. Write this. This is the velocity equation we have. Now equate the h dash of t is equal to 0 and solve for t. Just take this to the other side, make it positive, and then divide 9.8 by 19. So it'll be 9.8 t equals 19.6. Sorry for the handwriting. Divided by 9.8 on both the sides, you will get t value. So it's basically 19.6 divided by 2, divided by 9.8, that is 2. You can check it out in the calculator. It'll be positive because this goes to the other side, both will be positive. So at time 2 seconds, you will have the maximum height. Okay, but is this the answer? We don't have maximum height, we have the time at which the maximum height occurs. So now what you have to do is substitute in the height equation t as 2 everywhere, and that is your maximum height. See, all you need to do is substitute over here 2. H of 2 will be minus 4.9, 2 square plus 19.62. This is the answer for the maximum height. H of 2 will be, if you put this in the calculator, let's just check, minus 4.9 multiplied by 2 square plus 19.6 into 2. So this is the answer, that is 19.6 meters. So this is the maximum height. So we have found the second thing as well, but we have not found the last part, how much time is spent in the air by the ball. So find time spent in air. How do you find it? So we need to understand. The ball lands at h of t is equal to 0, right? Always look, say if you're throwing something from the base, if it's going from the base over here, it goes like this, and when it falls down, it will touch over here. So there'll be 2 points. See, it starts from here and it falls down over here, right? So when it touches the ground, basically, what is the height? Height is 0. So it starts from here, it goes up like this, and it falls down. So from this particular point, from 0, it is in the air. It is going, flying up, 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 and then it comes down. At h of t is equal to 0, this will be the second time, time 2. We need to find this particular time, because we will know from this time 1 to time 2, this is the a time. So how do we find that? It is very simple, because we just now saw we should just find the height 0. So this is the equation, right? Solve when this is equal to 0, you'll find the times. Okay, when it is launching and landing, we find both the times. So what we do over here is just make this equation h of t equals 0. Okay, so make it equal to 0, and then we will solve it. How do we solve this? It'll be minus 4.9 t square plus 19.6 t, right? Just, it's a quadratic equation, one side is equal to 0, so just put it in the calculator. Mod phi 3. Now what is before t square? It is minus 4.9. What is before t? 19.6. What is the last constant value? It's not there. Nothing is there, so it's 0. And one side must be equal to 0. The answer is t is equal to 4 and 0. See? It's at 4 and 0. That means the launching time, it starts at what? The initial velocity, it's there. 0 it starts and it reaches down at 4. Launching time is 0 and the landing time is 4. So how much time, how much seconds is the ball in the air? The amount of time the ball spends in the air is 4 seconds. Why? Because they launched at 0 until 4 seconds it reaches. So the graph in this, say it's 0 to 4. So this will be at 4, 0. This is the answer. To find the maximum height, this particular point at 2, it will be at maximum. We found out at time 2, we found the maximum height. So that is basically it. You can easily graph it as well if you want. But over here, the values are very important. Now we have a real world problem to find the initial velocity required to reach a certain height. We have the problem here. It has been reported that former basketball star Michael Jordan has a vertical leap of 135 centimeters. Ignoring air resistance, what is the initial velocity required to jump this high? Now over here, we have been told the height over here, the maximum height is 135. What is the velocity required to jump this high? Just like the previous problems, we will write the given. The initial velocity is not mentioned, so it's 0. H of 0 is 0. But what is this? H at time maximum. This maximum time we have 1.35. That's fine. What about the next thing? What is needed to be solved? That is the initial velocity for this particular jump. Okay, it is not initial velocity at any time. It is at this particular jump. Okay, we will come to that in a while. But how do we find velocity in general? Integrate acceleration. We have done this many times now. You can pause the video and start continuing for the next few steps at least. Now over here, when you integrate this 9 minus 9.8 meter per second square, we will get minus 9.8 t plus c. Okay, this is the velocity at any time t. Now, how do I find the initial velocity? V naught. That is at time 0, isn't it? H dash of 0. So, H dash of 0 is basically the initial velocity. At initial velocity, what is the time? It's 0. So now, H dash of 0 means initial velocity. What is the t? 0. So what is remaining? C. So this is the initial velocity, the constant of acceleration c value. So now over here, this h dash of t, you can write it as negative 9.8 t plus c. Why? Because that is the initial velocity you need to add to it. This much is basic. We have done this previously. Same thing is repeated. Now we need to find the height. We have done this as well. You need to integrate the velocity over here. So when you integrate the velocity, you get the position or the height. Over here, what is the integration of this? It will be 9.8 t square by 2. That is negative 4.9 t square. The minus sign, that's why it's minus. Over here, t square plus initial velocity f naught times t plus c. Okay, now why do we do this? Now what we do is we will find the see over here, we know what initial height, so we can find the c value. But this is not that useful, but we have to do it. I'll tell you why. C is 0, it's given. You should substitute over, you'll get 0. Now you'll get height. Okay, but this is not the height we want. It is h of t. It is not exactly what we want. We want initial velocity for this particular height. Now this doesn't make sense. This is not the initial velocity we want. We want at t max, at this particular 135 centimeter. Okay, I forgot to tell you one important thing. We generally convert it to meters. Why? Because we have acceleration in meters. So just convert this 135 to meters. It is 1.35 meters. Okay, this is just two zeros over here, so that's how. It's centimeter, it's 10 to the power minus 2. You have to take two decimals that side, it'll be 1.35 meters. Now over here, after this, till now it has seemed like the previous problems. I hope you recognize this. Till now it has seemed like the previous problems. Now what do we do? Here now we'll find the maximum altitude. How do we find the maximum altitude? In the last problem we learned maximum altitude, the height is maximum when the velocity is 0. It's increasing, it reaches 0 and then it decreases. So at that particular point, change in the direction happens. H dash will be 0. I told you in the last problem, it does not change. It's always standard. So that is always standard. Now, over here, we can see that at h naught is equal to 0, whatever happens is the maximum height. This height is maximum. So, h, we have the velocity over here, right? Velocity equation. H dash of 0, put it as 0 and solve what is remaining. You can get the time maximum. See, this basically h dash of 0 means it's at the maximum altitude, maximum height, isn't it? So whatever the time is there, that is the maximum time. So what we are doing over here is take this to the other side, it becomes plus 9.8, and t divided you have 9 point, see it's like this, 9.8 t equals v naught. So all we do is we will just divide both the sides by 9.8. You will get T max is equal to V naught divided by 9.8. Why do we write T max? Basically, that is the maximum time. That is the time, sorry, it's not the maximum time. It is the time where maximum altitude occurs. That is why it's T max. Now, the height at about time, at about this time, is always maximum altitude. Now, over here, this was the maximum altitude, isn't it? Look over here, we have this. T max is what? T max is V naught by 9.8. So instead of h of T max, we'll write h of V naught by 9.8 because this was the maximum height it was jumped. So this is a maximum altitude and that will occur at this particular time. T max, that is V naught by 9.8. Instead of T, we are substituting this. And now we will solve. In the initial velocity, see over here, the initial velocity, sorry, height over here, h dash. Here we got this as 0, so this is the equation. Here what you do is that initial velocity can be solved now. I'll tell you how. All you need to do is instead of t, put this value. Okay? Instead of t, you have to put this value. So you can see the time will be substituted into v naught. So now what is the unknown variable? It is v naught, so we can easily solve it. H of v naught divided by 9.8 is 1.35. You can write over here 1.35. Now t square is v naught by 9.8 square. Now what is negative 4.9 divided by 9.8 square? That is negative 5 by 98. You can do this in calculator. Let us just do it. If you're getting confused, see, just remember this negative 4.9 is outside, but the bracket, sorry, the it is like this. V naught, let's leave it. So it's 1 divided by 9.8 and square. Okay, so that is the answer. Or in simple understanding, you can just write minus 4.9 divided by 9.8 square. That is the answer, negative 5 by 98. Now over here, what is happening? V naught times V naught is V naught square. Look over here, the numerator also V naught becomes square and the numbers you can solve it. Now what is unknown? Only V naught. So add these both. Add negative 5 by 98 plus 1 by 9.8. So 5 by 98 is the answer. So over here you can get 5 by 98 V naught square. Now take this to the other side, 98 to the other side, multiply by 1.5 and divide by 5. The answer is 26.46. What do we do? 1.35 numerator, denominator comes to the numerator over here. So it's multiply by 98 divided by 5. The answer is 26.46. Now this is not the answer. Square root of 26.46 is the answer. That is 5.14 meter per second. So this was the velocity required for the vertical jump by Michael Jordan to reach the height of this. So the jump was at this velocity and then only you can get the maximum altitude of 135 centimeters. In this problem, we will see the motion of a projectile in two dimensions. An object is launched at an angle theta equals pi by 6 from the horizontal with the initial speed of v naught equals 98 meter per second. Determine the time of flight and the horizontal range of the projectile. This is very important. Now, before we understand better, we will see some diagrams. First thing, write the given. Angle is given pi by 6. Initial velocity or v naught is 98 meter per second. Okay. Now sketch the graph. You can see a projectile, that is object, is launched like this from here. Okay, and as it goes it will reach somewhere down. Now this is the angle that is formed and this is the initial velocity. Now you can see over here, if we draw a proper figure, I mean at this part, if we draw a 90-degree diagram, that is, just see this line. Okay, that is v naught, isn't it? Now let's make horizontals. So let us make a horizontal line and a vertical line. What happens is, if you use trigonometry, sorry, not Pythagoras, trigonometry, or based on unit circle, before, you must have seen this. If this is the hypotenuse, what is going to happen over here? This can be written as hypotenuse cos theta. Why? Let us see. This is the horizontal, right? That is x. What about this? This is y. It's the vertical line. X-axis, y-axis. Now, what is x over here? No need of asking. Sorry, I asked the wrong question. What is x? No, what is cos theta over here? That is a better question now. Cos theta. Okay, this is the angle theta. This is 90 degrees, isn't it? Cos theta will be adjacent over hypotenuse. So, what is adjacent? X over v naught. So, what is exactly x only? So the horizontal would be V naught cos theta. So this is the answer for x. Same way, y is equal to, sine theta is equal to y by V naught. It will be V naught sine theta. That is what happens. That is why you get these two components, the vertical and the horizontal component. And this is the figure over here. We will come to this in a while because this is the final figure. But this, you do not need to know all this. Only this diagram for your understanding and the components. If you know this much, that is enough. Now we need to understand what needs to be solved. We need to find the time of the flight t. We have done similar problem before where we found the launch time, landing time, similar to it. In the previous sections, we have done time. But this horizontal range of the projectile is the first time we will be solving, which we'll be doing now. As usual, let us start with the acceleration and integrate this to find the velocity and then the position. Now, how do we find the velocity? Integrate this, it will be minus 9.8 t plus c. Over here, initial velocity and theta is given. So remember, the initial velocity in the vertical component and the horizontal component needs to be solved. We are just not solving. Why? It's not just vertical, not just horizontal like previous sections. Now over here, there are two components, vertical and horizontal. So let us first deal with the vertical component, okay? Now let us deal with the vertical. What is the vertical acceleration? This is the vertical acceleration minus 9.8. Okay. Uh, Now, if you're thinking about horizontal acceleration, can anyone tell me what is horizontal acceleration? Horizontal acceleration is basically zero. Okay. Only the vertical gravity acts downwards. Horizontal will be zero. It won't be pushed right and left. It's nothing is mentioned. Okay. Only the vertical acceleration. Remember, this is the vertical section, vertical parts we are solving in the vertical component. Important to know that. Okay, this is vertical component always. Now, since it is, we are dealing with vertical component, the initial speed velocity would be y dash of 0. What is it? Y dash of 0 in the vertical component is this one, v naught sine theta. Okay, now substitute the theta and v naught value. I'll repeat again. We are dealing with the vertical velocity, vertical position in this part, this first step. So we will have to deal with the straight parts. So the acceleration over here is negative 9.8 meter per second square. And we are dealing with the initial velocity of v naught sine theta, the vertical component. Okay. Then what we do is we will have to write y dash of 0, that is substituted 98 into sine of pi by 6. Now how do we solve this? I hope you remember this. Whenever you're dealing with pi or radian, it's not degree, so you need to shift mode and put 4. Now let us solve this directly. 98 sine pi, that is over here, shift divided by 6 and close the bracket, and the answer is 49. So the initial y dash of 0 will be 49. So what do we do with that? Put it over here in this equation. Sorry, let me just go a little back. Over here, instead of c, y dash of 0, right? Y dash of 0 means this component becomes 0. So c will be 49. So that is the thing. Now we can find the position, integrate this simple as it is, just integrate it. It will be minus 4.9 t squared. Now since it is 49 over here, it will be 49 t plus c. Again, you need to find the initial altitude. They have not mentioned anything. It is launched. That's it. Did they tell it's launched from 10 meter or 20 meters? No, nothing. So you should consider it 0. Okay, altitude initially is 0. The height is 0. Now, over here, when you solve y dash of 0, what happens? This cancels, c is 0. So therefore, we are not writing this part. Okay. I just realized I've done one mistake. I apologize for it. It is t over here. Is that clear? Why? Because over here we are minus 4.9 t squared plus 49 t. This is 0. Okay, I missed the t. I apologize for it. Now the step 5 is finding the time of flight. How do we find the time of flight? Okay, we had seen the figure. Now what happens is you're throwing something. So imagine it starts like this, it'll go over here and it'll fall over here. Now when will it be, what is the times of, what are the times? What are the two times? Whenever it touches the x-axis, that means this position must be 0, isn't it? See over here, y of t, y of t must be 0. At that time you can find the touching or the launching or landing times. So basically at this y of t, that position function, when it is 0, when the position is 0 at this axis, that means it's the x-axis. Okay, what happens? You will see that the projectile, when it is thrown, it starts over here, and when it falls down, it touches over here. So just remember, whenever you equate y position as 0, y of t is equal to 0. See, y of t is equal to 0. You can find the times when it touches the x-axis. I've written over here t, okay, but I missed the t over here only. So now let me do that. We have solved the similar thing before as well to find the landing and the launching time. So the same concept over here. Now what do? I will have to go to mode 5 and 3. And the first section, it is whatever is the coefficient of t square minus 4.9. Next one is 49t, okay, that is 49. And last one, the constant over here is 0, so that is 0. The answer is 10 and 0. So that means over here it starts at 0 because it's thrown at 0, and then it reaches at 10. T is equal to 10 seconds. So what do we understand? The launching time is 0 seconds initially, and landing time is 10 seconds. This is very useful information because this is the time of flight. So that is the time of flight. Time of flight is 10 seconds. Total, how much time of flight? From 0 to 10, that is 10. If you scroll before in the previous problem, the launching time was 0 seconds itself, but the landing was 4. So the time of flight was 4 seconds. In this, it's 10 seconds. Now, step 6. Over here, we finished time of flight. What is remaining? The horizontal range of projectile. Now we are dealing with x acceleration. Now you can see x double dash. In the previous section, it was y double dash. It was vertical. Now it's horizontal x double dash. What happens? Over here, velocity will be the integration of x double dash of t, that is integrate 0. It is just now over here. Okay, again, is it missed? Okay, it's 0, sorry. 0 means it's 0, only the constant plus c is there. Why? Because you do when you integrate 0, you'll get again 0. Okay, it will be 0t plus c. Okay, I hope this is clear. That's the thing. Now what next? Find the initial component of velocity. So how do we find initial component? In the previous section, y dash of 0, we took v naught sine theta because that is relating to the vertical component. Now initial velocity in the horizontal component, it will be v naught cos theta. So x dash of 0 equals v naught cos theta. Then over here, what you must do is basically v naught is given, that is 98, cos theta is pi by 6. Same thing in the calculator, but make sure you're in the radians mode. So that is very important to be in radian mode. 98 cos pi divided by 6 will give you the answer 49 root 3. Okay, that is equivalent to 84.87. Now, here, what is x dash then? X dash of t. It's the same thing because x dash of t is 0. That initial velocity is only the thing. Whatever the c value, that's it. Okay, that is fine. Now, over here, how do you find the position? This is the velocity. We need the range, okay, but we'll come to that. What is the position function? Integrate this, you'll get the position. How do we integrate? Now integration of 49 root 3 multiply t, that's it. It's a constant, right? Only when it is 0, 0 will be gone, so only c will remain. Now over here, x 49 root 3t. Okay, now we have to write the plus c over here. But what happens over here? What is the initial position? It is 0. When you solve it, the c value will be 0. As we have got over here, can you see the initial altitude? Okay, it will be 0. So we do not write it again and again because it's the same thing. You will understand it. What is known? The initial velocity is speed. So only the velocity will change. This will be 0 over here. The c plus c will be 0. So we do not write it. Okay, just remember that because now by now you have solved so many times, you must be thorough with that. Okay, directly we have written x of t 49 root 3. Now how do you find range? Range means how much distance it has covered. We know x of t, the horizontal range is 49 root 3t. What is the time when it touches the ground? It is 10 seconds. So 49 times root 3, if you multiply by 10, you will get the range. See, you have to just put the landing time or time of flight. The time of flight was 10 seconds. So over here, just multiply t by 10, you will get the range. I'll repeat again. What it means is, see, this is the projectile, right? It starts from 0, it goes over here. Now, the position along x-axis is known. See, this is the position along x-axis. That function is known, okay? Now, if you multiply time t, you will come to know the distance from here to here. So all you're doing is multiply the time t with this position function instead of t at 10, x of 10. That means you will come to this particular horizontal axis, right? This distance. So that is 48.7 meters. This problem is another interesting problem. It is about motion of a tennis serve. It is basically about the game of tennis. We will read the problem and then see over here. Venus Williams has one of the fastest serves in women's tennis. Suppose that she hits a serve from a height of 10 feet at an initial speed of 120 miles per hour and at an angle 7 degrees below the horizontal. The serve is in if the ball clears a 3 feet high net, that is 39 feet away, and hits the ground in the front of the service line 30 feet away. Determine whether the serve is in or not. So now what they have done is they have told some basic details of what the server over here, in this case Venus Williams, she is one of the most famous women tennis player. So she is serving, and over here they have given all the basic details of the serve, and we must see whether the serve will be in or out. So now this is the court over here. This is the net. It is 3 feet, and then it must go above it. If it touches this, it's a foul. It's not a proper serve. It will be, and also if it falls outside the service line, it is not a proper serve. So it must be falling inside. Now they have told the speed, everything, and whether when she hits over here, whether it will reach within this or no. That is what we need to find. Okay. So the court over here is 39 feet, but the service line is 60 feet. It is similar to what we have done before. We need to start with, okay, we need to start with the acceleration, velocity, position, the same thing. But over here, there is one important thing. This dash means feet. This is feet, 10 feet. You can see 60 feet, 39 feet. But then we have 120 miles per hour. So we have to convert to the same units. You can't keep different units. Now, it is better to convert this miles to feet. Why? Because you can see so many things are in feet. Now, it is better to convert this miles per hour to feet per second. So what we do is we convert this to feet per second. How do we do that? Now, if you're getting confused with this formula of conversion, it's very simple. If you have checked before, what is miles to feet? Now, miles to feet, if you have 1 mile, how many feet is it? It is 5,280 feet. If you have checked it online, or if you have just checked it, it'll be about 5.3 thousand feet. Okay, 5,300 feet. That's what we generalize. Exactly, it is 5280 feet, 1 meter in terms of feet. Now, what about the hours to seconds? Hours, how many seconds it is? 1 hour is 3,000 seconds, 3,600 seconds, sorry. So now over here, miles per hour, that means miles divided by hour. Now you need to convert this to feet per second. So what happens is miles to feet is multiply 5280 up, but this hour is down, hour to second, divide 3,600. Basically, you're multiplying over here to hours. So that is how we get feet per second. So basically, you should just remember 120 miles is up, so 5280 divided by hours 3600 is down. And this theta is very important as well. Look, the person over here is hitting from like this. See, from top to down. It is going downwards from the horizontal dimension. That means this angle over here is 7 degree, yes, but downwards that is minus 7 degree. That is another crucial thing. And the initial height, where is the initial height? It is 10 feet. You can see over here, the serve is from the height 10 feet. So H naught is 10 feet. All this initial speed converted, theta is degrees and height. Now what do? We need to start solving. Now start with the vertical component. Always we do the vertical component and then we go to the horizontal. So now over here, vertical component of velocity and position function. Okay, this is another important thing. We have 9.8 meter per second square. This you need to memorize it. It will be 32 feet per second square. Okay, when you convert meter to feet over here, it is always, see, this is miles per feet. Don't get confused. Now over here we are from meter to feet. It is 32 feet per second. So instead of 9.8, just remember it is 32. Then it's negative because it acts downwards. Now acceleration integrated to get velocity, it will be minus 32t. Okay, now don't forget the constant. Why? Because it will change. Over here we have initial velocity and all, right? So now y dash of 0, we have done this in the last problem. It's the same thing. The same thing will be now repeated. What do we do? Y dash of 0 is V naught sine theta. The angle is minus 7 and the V naught is 176. Just put it in your calculator. But it should not be in radians. It should be in degree. You can clear your calculator. Shift 9 3 equal AC. Now we will put 176, sorry, 176 multiplied by sine minus 7. That is the answer. That is minus for 21.45 feet per second. Negative, okay? Because it's going acting downwards. Now, over here, that is the c value. Now, what about the velocity function? Over here, instead of c, put this minus. All you have to do is minus 32t minus 21.45. Okay, that is the initial velocity component. Now, sorry, that is the velocity component at time t. We have done the same thing before, but we use 9.8, just that we are over here using the feet per second square. Now, next would be position, right? Let's do the position. What is y dash of t? Integrate the previous just now velocity function. Integrate this. Over here, it will be minus 32t square by 2 or minus 16t square and minus 21.45t plus c. Now it is not 0. C is not 0. In the last sometimes it will be 0. Why? Because initial height is always starting from 0. But here they have told, right? Initial height is how much? 10. Y of 0, H naught, Y of 0, initial height 10. So here this C value will be 10. If you put over here T is 0, 0 and this will be 10. So C value is 10. That's how we get this. Okay, now we found out the height equation. This is all about horizontal component. Sorry, vertical component. I'm sorry. See, guys, just remember. One second, let me go back. See, this is all vertical component. Okay. Now, let us do the horizontal component. Same thing, but horizontal component, we know the acceleration is 0. Now, integrate this. How much will you get? It is 0 plus c. So, we don't write 0. 0t plus c will be 0 plus c or just c. Now, over here, initial velocity component. We have done this in the last problem. Same thing. X dash of 0 will be v naught cos theta. Okay. Now, x dash of 0 equals 176. Why? We had found out when we converted this 120 miles per hour, it will be 176 cos minus 7. Put this in calculator, you will get the answer. We had already done for sine, just change it to cos. Now 174.69, 688, that is 69. That is initial velocity. Okay, now what next? We have to find the that is already found, sorry. That is over here. Why x dash of t is equal to 176.69? Because this just equal to c, right? So whatever is the constant of acceleration or the initial velocity component, that is it. That is the at x dash of t as well. So next, what happens is position by integrating the above. When you integrate this 174.69, you will have to multiply by t. Now over here, write the cases for the serve to be in. Okay, this much is over. Now we found out the vertical component position and velocity, horizontal component velocity and position. What next? We need to find these criteria, whether the serve is in or out. All we found out is very important to apply over here now. That is basic. Now over here, let us see the cases for the serve to be in, because when a tennis player shoots, the serve must be inside. If it's out, it must be redone. So from the figure, the ball to clear the net, what they have told, must have the distance over here greater than 3 feet at when? When the distance is over here, horizontal distance is 39 feet. What is the vertical distance? 3 feet. It must be more than 3 feet. Why? Because if it is less than 3 feet, if it's 2.9, it will fall inside, right? It must be more. So how do we do it? So over here, from the figure, to the ball to clear the net, vertical position, that is y dash of x, must be greater than or equal to 3 when the horizontal position is 30 exactly equal to 39. And what is the next condition? Next condition, when it lands, landing means what is the position, the vertical position? When it is landing, the vertical position is 0. It touches the ground, right? So over here they are told 3 feet. Yes, it's coming like this at 3 feet. Okay, the distance is 39. Fine. Landing means it is 0. Y is equal to 0. So this y of 0 is equal to 0. Sorry, let me go back. Y of 0 will be 0. And what must be the x value? X must be less than or equal to 60. This is the condition. Now let us solve for it. We will see one by one. The case 1. All you need to do is substitute in the position this thing equation. X of t is equal to 174.69t. We found out, right? Over here, just substitute x of t is equal to what? 639. So now solve for time t. What is the time t? T is 0.223 seconds. That means, let us see, at the time t, what is the y of t value? This y of t value must be more than 3. So all you need to do is substitute this time t over here, and what do you get? Everywhere, wherever t is there, put 0.223 everywhere. All you need to do is solve. You will get the answer 4.42 feet. Is this greater than 3? Absolutely. So the first case is good. The case 1, yes. So what we did is, the distance we know must be 39 feet. So we find the time at that feet. What is the time when it reaches this horizontal distance? It is 0.22 seconds. Now substitute this in the horizontal vertical component of position. So at 0.22, the height is 4.42. It is greater than 3. Fine. Now, what is the next? Yes, the clear enough to clear the net. Fine. But what is the next thing? When the ball lands, that means y of t is equal to 0. The distance must be less than 60. So let's find the time when the ball lands. How do we do it? Make this equal to 0 and put it in mode 5-3 calculator. You will get time. Take only the positive time, that is 0.37 seconds it requires when it touches the ground. So substitute this time in the horizontal distance. Over here, when you substitute this time 0.37, what is the answer? You're getting 64.6 feet. That means it is not less than 30. It is greater than 30 by 4.6. So if this is the service line, just go out over here. By little, it is outside. So basically, it is not enough. See, the ball is uh, not high enough. No, it is, yeah, it is not, it lands away from the service line. So basically, see over here, the serve lands beyond the service line, so it does not clear the service. Okay, so whenever she hits in that height, it will go above the net, yes, but it will fall outside the service line. So no, the serve is out. It's not in, it is outside. So one of the condition is not met in the case 2, so it is out. So this is how we can solve this problem. Now we will see problems where we will ignore the air resistance, but the answer will be so weird. So what is this air resistance? Before we start, in the previous problems you have seen, they have told ignore air resistance, ignore air resistance. Now before we get into the topic, imagine you are, say, somewhat 100 feet above, somewhere over here in a higher platform. You will throw a stone of certain mass, certain size, and you will throw a ball of cotton of the same size. Okay, cotton. What happens? The density is more over here. The mass is more, the mass is less in cotton. So when you throw it up from up to down, the stone or the ball or a heavy object will always go down. The air resistance is ignored over there because it doesn't make much difference unless the winds are very, very strong. Whereas if it's a cotton, if it's lightweight, it's not going to fall at the same time. Why? Technically, it doesn't matter if it's a feather or a hammer. If there is no gravity, it must fall. Sorry, if there is no resistance, it must fall at the same time. But here, since air resistance is there, this will not fall at the same time. Okay, the ball of cotton. It's like dropping a paper. When you drop a paper, what happens? Air resistance will make it fly everywhere, right? This is the thing. Now, let us take a consideration of raindrop, a small raindrop. Let us see over here, if we ignore the air resistance, what happens? The question is, suppose a raindrop falls from a cloud 3,000 feet above the ground, ignoring air resistance. How fast would the raindrop be falling when it hits the ground? If we ignore. Same thing what we have done in the previous problems is repeated now. So I will quickly skim through these. Initial altitude is given as 3,000 feet. That is y of 0. Then initial velocity is 0. Why? Because it's not mentioned and it is starting from the 3,000 feet up above. Find the vertical component of velocity from Newton's law. Now use feet, not meter per second. It is negative 32 feet per second square. And to find the velocity, integrate this. You will get minus 32t plus c. What is the initial velocity? 0. So when you substitute over here, the c value will be 0. So you can make the 0 and you will get this answer. I've not done that step, but we have done it in the previous videos. So you have to make t is 0, minus 32 0, and c will be 0. Because y of t is 0, y dash of 0, sorry. Same thing now, start with the next thing, the vertical component of position, integrate this over here. When you integrate negative 32, what happens? You will get negative 32t square by 2, it will be negative 16t square plus 3 plus c. Now, y of t is negative t square. Now, what is the initial altitude? When y of 0, t will be 0, but c will be equal to 3000. So, given over here, we write it as 3000. Okay, what next? Now over here, find the time when it hits the ground. That means, see, it starts at 3000, right? The rain drops somewhere over here in this cloud, okay? That is a very weird looking cloud, but just for understanding's sake. The ground is over here. The height difference over here is how much? 3000. So this is 3000. As it comes down, what is going to happen? The value of y reduces, it keeps on reducing and it reaches 0. So when y of t will be equal to 0, we need to find when it hits the ground, isn't it? So let's see, when y of t is equal to 0, for this equation, solve the time. How do we do it? Take out the calculator, mode 5 and 3. It'll be minus 16, 0 because there is no theta, and 3000. The answer is negative 13.69 or negative 13 points, sorry, positive 13.7 and negative 13.7. You can do this like this, or you can just solve it by taking this to the other side and taking the square root. It's up to you. It's the same thing. Answer will be same. Now you can see the answer is two answers. Time cannot be negative, so just take the 13.7. Now one thing before I forget, over here you have negative 13.2. Why is this? Because it's moving downwards. Okay, that is the thing. Acceleration is going downwards. So now we got the time at which it hits the ground. So from 3000 feet to reach the ground, it will take 13.7 seconds. Now how do you find the total the velocity? What is the velocity equation over here? Substitute instead of time 13.7. So that will be at the velocity at 13.7, means the velocity when the raindrop is hitting the ground will be minus 32 times 13.7. Let's do that now. Over here, so y dash of t equals minus 32t. So all you need to do is over here substitute 13.7 because that is the time it takes for the raindrop from the cloud 33,000 feet above to hit the ground at 0 feet. So now when you multiply 13, you will get this answer. It is minus 438.4 feet per second. Negative sign because it's going downwards. But look at this. Isn't it insane? Because the speed over here, raindrop, in terms of kilometer per hour, it is nearly 500 kilometers per hour. Just imagine the raindrop falling on your head or your body. It will be so painful. Why? Because it's nearly 500 kilometers per hour. Now, does it really happen? The raindrop, does it fall in this speed? No, the actual speed of the raindrop is just 16 kilometers per hour. Because of the air resistance, it reduces. But if air resistance is ignored, this is the case. But we cannot ignore the air resistance. So this is very important to know. What is it? That this certain things You cannot ignore air resistance, and the thing is, the speed or the velocity reduces because of air resistance. In the coming section, we will see about Magnus effect, or where air resistance cannot be ignored. So please stay tuned for the next video. Now we move to the last topic of this lesson, and it is also the last topic of this chapter. But before I continue, I want to tell you, first of all, thank you for all the subscribers. It means a lot. And thank you for all the love, the wishes. I greatly appreciate all of you. And if you have not yet subscribed and if you have found these videos helpful, please do subscribe for this channel and do share it with your friends who might find it useful. Now, getting back to the topic, here we have equation of the motion ball. Before we come to this equation, I will give you an instance, real life instance. I'm sure all of you watch football, or at least all of you know about football. And sometimes you might see a, sorry, no, that's not a proper ball. Okay, let this be a player. He will hit the ball. Over here is the goal post. Okay, imagine he hits it. He won't hit it straight. Obviously, the goalkeeper will catch it. He won't hit it like this. Sometimes he will hit it with an angle and it will incline and go inside. Okay, what I'm trying to say is, if this is the person, he'll hit the ball, it'll incline and then go inside the goal post. You might have watched many videos like this. So what is that? That is the knuckleball effect. It is from the Magnus force. So what happens is, because of the air, when you hit the ball, this will start rotating, tilting, and then that angle forms. So now we will study about that, little bit basics of it. Not in detail, but just that you must remember this formula when it's a knuckleball equation. The acceleration x double dash t is equal to negative 10 sine 4 omega t plus theta naught. We will see this in detail now in this problem. Over here, the spinning rate, that is the omega, the spinning rate, 2 radian per second it spins, and the theta naught is 0. Find the equation for the lateral motion of the knuckleball and graph it for time from 0 seconds to 0.68 seconds. Now, over here, we need to know this formula. This is the Magnus force equation. Substitute all that is known. Here, minus 10 sine 4 omega is 2 substituted and theta naught is 0. Now, this will be equivalent to minus 10 sine 80. Okay. Now, we need to find the velocity, that is, integrate this. What happens when you integrate it? Now, if you're wondering how you get this, can you directly integrate sine? Okay, sine is negative cos. Fine. But how do you do it? It is 80. You have to do u substitution. So now I want you all to start u substitution and try to do this. I'll tell you the basics, basic of u substitution over here. It'll be u equals 8t and then you need to solve it up. Okay, what will be du? It'll be, you need to derive this and so on. You need to solve it. It'll be du is equal to 8 du by dt, sorry. What is dt? Take this to the other side, it'll come down, so you will have du divided by 8. So that's why it's 1 by 8 over here, okay, when you solve it. Try this u substitution method. You have done this before. So when you solve it, you're going to get this particular answer. Plus c, constant of acceleration. Now, what is the initial velocity? Okay, before that, now over here it's rearranged. Negative 10 by 8 cos 8t plus c. Negative 10 by 8, sorry, my bad. Over here the negative goes and it becomes positive. So it's 10 by 8 only. And what is 10 by 8? It is 1.25 cos 8t plus c. Now over here, remember, we need to find the c. So let us find what is the initial velocity. It's not given, it's 0. So substitute over here 0 and solve. But remember, don't directly take the answer. Why? C value varies. In the previous videos, in the previous sections, I told you the C value varies when it is trigonometric function. Here we have a trigonometric function, that is sine or cos. What happens? The C value may vary, may change. If it's 0, it may not be 0. You need to substitute. X dash of 0 is 0. Yes. Now put over here in this equation everywhere 0. So x dash of 0 equals 1.25 cos 8 into 0 plus c. Now 8 into 0 is 0. Cos 0 is how much? 1. You can try it in the calculator. Sine would have made it 0, but this is cos. So 1.25 into 1. Now take this to the other side. It will be minus 1.25. That is c. This is the thing. Now what next? You will have x dash of t equals 1.25 cos 80 minus 1.25. So this is the answer. Then we have x of t, to that is the position. Integrated again. We have done the same thing, right? We are doing it over and over. Now one thing over here, you can simplify it by removing this common out, but don't use it when you're, when you're integrating. You will allow to split it out. But if they have just asked you the velocity or something, this would be the answer. If this is not there in your options, this might be there. Okay, now integrate this particular equation again. What will you get? Again, u substitution. I hope you know the u substitution. Take this as u and solve it up. And over here, cos becomes sine. It will be integration of cos is positive sine 80. Because of u substitution, you'll have 1 by 8. They get you 1.25 t plus c. Now, what is the initial position? 0, not mentioned. So what do? It is x of 0 is equal to 0. Substitute wherever t is there as 0. Now since it is sine function, everything will become 0. Okay, sine 0 is 0. Multiply anything with 0 is 0. Over here also minus 0 plus c. This is also 0. Now you will get the position. Sorry, over here. This is the knuckleball equation. That is, this is for the motion. 0.156 sine 80 minus 1.25t. Now, how did we do it? By integrating the acceleration equation. This is a kanun, like a formula. You must by heart this, integrate it with the given values of omega, that is the spinning rate, the theta naught is the angle. Put it over here and then solve it, integrate it. Use substitution for integration, and then you got the final equation. Now this can be graphed. X of t can be graphed from 0 to 0.6. The graph will be something like this. How do we graph it? Since it's very small numbers, take small values, 0.1. Put over here instead of t as 0.1. How you can do it is, so it will be just very simple. 0.156 into sine 8 into t, that is, let me take 0.1, 0.2, 8 into 0.1, multiply minus 1.25 t is 0.1 plus equal to, what is the value you're getting? 0.122. See now over here, it is about 0.122. Same way, change the value to 0.2. I'll just change it over here, make it 2, and make this to 2. You will get over here. Okay, now, is this the correct values? Very good, this happened. Anyways, now is this the correct answers? What is my mistake? I have to change this to radians, guys. I forgot to change it to radian. Now I will get the correct answer. This is the correct answer. Okay, it is close to 0.1. Look, 0.2 is close to 0.29. That is 0.09 or 0.1. Okay, let me take another value, 0.4. It should be somewhere 5. Okay, let me take this, the graph. Over here, it will be 0.61. Let me check 0.4. If it's draw a straight line, okay, it's not straight enough. It is around that. Okay, it's around 6.1. Okay, make sure always it's in radian mode. Okay, that is, my lines are not accurate, but if your lines are accurate, you will get it. But make sure you are using accurate mode, that is radian, when you're using trigonometric function. We have done that before, so if you do not use radian, you will not get the correct answer. So please make sure about that. Okay, then you can easily get it. Sorry, I have used 0.5 and 0.4. Okay, so please make sure you use it properly. I have done many mistakes. Now 0.5 is over here. It should be 7 4. Let me draw a straight line, and it should be a straight line and something over here that is about 0.4. Yeah, mine is not very accurate. 0.7, sorry, 0.74. I don't know why I'm missing numbers. Maybe because of the last video and I'm just tired, I guess. Sorry for that. Now, I hope you understand the concept. How you do is take different values of t and check the graph. If this this problem will come in the, as MCQ, you will have the graph. You can easily check the graph in this equation. Just put the x values. Instead of t, you should put x because it's x of t, and then you can check the y values. All are a negative quadrant. The correct graph will give you the correct answer. So this is how you can easily solve it up. Only thing in this is remember this particular formula and then integrate it. We have done this integration many times to find the velocity position. The position is the equation which you have to solve for lateral motion. Okay, and then you can graph it. So that is the end of this lesson and the end of this chapter. Stay tuned for the next chapter. I will be starting to do the explanation videos soon for the next chapter as well. Till then, happy learning and all the best. See you soon, guys.